Swayam Prabha. Digital India. Educated India.
So, I have this beam, this is steel, this is wood. For dimensioning purposes, let me say this is of depth d, this is of thickness t, and this is of width, both are of width b. Okay. Now, what happens? I have to find y naught, wherein I have to integrate E of as a function of y into y dAx. dAx is dy dz divided by integral E of y dAx Ax. Let me assume that the y and x of the cross section is measured from y and z of the cross section is measured from here, y and z. Okay. Now, I have to find y naught, which is given by that expression. I decompose, since integrations I can decompose the area over which I integrate additively. I can rewrite this as this integration as integral E wood y dAx Ax of wood plus integral EST into y dAx Ax of steel divided by integral E of wood dAx Ax of wood plus integral Ax of steel EST dAx. Okay. Now, this I can pull out now, I can pull out EW and EST outside the integration because they are constants. So, I will get it as EW into integral y dAx Ax of wood plus EST integral y dAx Ax of steel. If I do the same thing at the bottom, I will get EW into Ax dAx of integrating dAx over Ax of wood would be the area of the wood plus EST into Ax of steel, area of steel. Okay. Now, this y dAx is nothing but the center of the wood region. Okay. Yax is center of the wood region times the area of the wood region. So, that will be EW, the center of the wood region is measured from the origin assumed would be d by 2 is the center from the wood bottom surface, but from the steel bottom surface it will be d by 2 plus t into Ax of wood, area of wood, that will be the integration of y dAx of Ax of wood, okay, plus EST into Ax of steel, area of steel into t by 2 into t by 2 is the distance of the center of the steel from the bottom panel, bottom fiber. So, this is YST and this distance is Y wood, this is Y wood and this is Y steel. Okay. Okay. And then I have divided by area of wood, which will be d times b plus t times b. Okay. Now, I do a simplification, I pull out EW outside. So, I will get d by 2 plus t into area of wood is b into d plus EST by EW into b into t square by 2, okay, divided by, again if I pull out EW, this will be d plus EST by EW BD into BT. Okay. Now what I want to define is, I want to define some factor called m. M stands for modular ratio, which is defined as, in this case I am defining it as EST by EW, Young's modulus of steel by Young's modulus of food. Okay. Then what happens is, I can rewrite this equation as d by 2 plus T into dB plus m times B into T square by 2 divided by BD plus m times B into T. Okay. So what I am going to do now is, I am going to change the width of the steel to m times the width of the steel, where m is a modular ratio. In that sense, I can make this beam a homogeneous beam as though it is made up of wood. Okay. So typically this modular ratio EST by EW will be of the order of 10. Okay. This ratio will be of the order of 10. So I have to increase this by the width of the steel by 10 times. So I will have a cross section something like this. Okay, this remains as T, this remains as D, this is 10 times B, and this width is B, that width remains as B. Okay. This is a equivalent wood section for this from this analysis. Okay. In other words, if I simplify my y0, I will obtain this as y0 will be d plus 2t into d plus m t square by 2 times d plus m times t. Okay. I cancel the b throughout, and that is what I will get as y naught. Okay. Now I have estimated y naught. Now let us go ahead and estimate the other term which appears in the denominator to mz moment. Let us now compute this term Ey into y minus y naught whole square dA. Okay. Okay. So for this beam we have assumed, we have computed y naught as d plus 2t d plus m times t square divided by 2 times d plus m times t. Okay. Now for the same section, steel and wood of depth d, t and width b, I am interested in computing IZZ, not IZZ, I am interested in computing E times y, y minus y naught whole square dAx, AX. Okay. Where y naught was some distance here, this is y naught. Okay. And remember, we took the axis as this as y and this was z. Okay. So now what will this be? This as usual I can demarcate into Ax of wood, EW of wood, that is y minus y naught whole square dAx plus EST of steel integral y minus y naught whole square dAx, Ax of steel region. Okay. Now since EW is a constant, I can pull EW outside, integral y minus y naught square dAx, Ax of wood plus EST integral y minus y naught whole square dAx, Ax of steel. Okay. Ax of steel. Okay. Now this will be EW into if first I will do by integration, then I will do it by another method wherein I will use the parallel axis theorem to shift the areas and do that. So for A of wood, it will be from y minus y naught whole square dy integrated from t to d plus t and dz integrated from minus b to 0, okay, integrated from minus b to 0, because that is what the area of food is, plus est into dz of steel is again minus b to 0 into y minus y naught whole square dy integrated from 0 to t, okay. So, this will be EW, if I pull it out, it will be b, dz is integrated, dz is z, when I apply the limits it will be b into this will be y minus y naught whole cube by 3 from t to d plus t plus est by EW into b, again integrating dz you will get it as z, 0 minus b to 0 will be b, and this will be y minus y naught whole cube by 3 from 0 to t, okay. This is nothing but EW into b, this will be d plus t minus y naught whole cube minus t minus y naught whole cube into m times t minus y naught whole cube minus plus y naught cube, okay. Now, what I want to do next is, instead of doing the integration, if I were to use the parallel axis theorem for finding this integration, for doing this y minus y naught whole square dAx of Ax of wood and this of steel, I will get the same thing as EW into about the central axis of the wood, which might be here y wood Cg and z wood Cg. You know that it is BD cube by 12. So, I will have BD cube by 12 plus I will have the area of the wood, which is B into D times this shift in the Cg of the wood to the Cg of the cross section or the effective Cg of the cross section. So, that would be that distance would be d by 2 plus t minus y naught whole square, okay, y naught whole square, that will be for the first integration, that will be for this integrating the wood, that will be integrating for the wood. Now, doing it for the steel, I will have plus est by EW, since I have pulled out the Young's modulus of wood outside, that will be the for the steel again I will have the Cg of the steel to be here, this y steel Cg, that will be, this will be z steel Cg, okay. So, about the Cg axis I will get it as b t cube by 12, okay, plus b into t, which will be the area of the steel, into this distance squared. I have to find this distance, I have to square that distance, that is the parallel axis theorem, okay. So, that distance squared would be y naught minus t by 2 the whole square, minus t by 2 the whole square. So, that is this expression, okay. Now, you have to show that these two are equivalent. So, I have to show basically BD cube by 3 plus BD into d by 2 plus t minus y naught the whole square is equal to that expression. I will show that, and I will assume that for the steel also the same thing happens, okay. So, I have to simplify this, I have to simplify this expression. So, I will have BD cube by 12 plus BD into d by 2 plus t the whole square plus y naught square minus 2 y naught d by 2 plus t, right. Okay. So, this will be BD cube by 12 plus B d into d square by 4 plus t square plus dt plus y naught square minus y naught d minus 2 y naught t. Okay. So, this is nothing but BD cube by 12 plus BD cube by 4 plus BD into t square plus dt plus y naught into y naught minus d minus 2t. Okay. So, this will be nothing but BD cube by 3 plus BD into t square plus dt plus y naught into y naught minus d minus 2t. Okay. Now, let us expand this term, let us expand d plus t minus y naught whole cube into b minus b into t minus y naught whole cube. This will be b into d plus t the whole cube minus y naught cube, or let me do it the other way around, it will be d cube plus t minus y naught whole cube plus 3d into t minus y naught into d plus t minus y naught, okay, minus t minus y naught the whole cube. Okay. So, this will be now equal to, I left that 3 outside, 1 by 3 is there, this will be b by 3, this will be b by 3 d cube plus d into plus bd into, I move a t minus y naught inside. So, it will be dt plus t square minus y naught or plus y naught into y naught minus d minus t minus y naught t. Okay. So, this will be equal to bd cube by 3 plus bd into dt plus t square plus y naught into y naught minus d minus 2t. Okay. This is same as what we got before. So, these two expressions are identical. So, there are couple of ways by which you can compute this integral e of y minus y naught dAx. One, the simplest way is what I did the last, basically you pull out the Young's modulus which is constant for a region and then use the parallel axis theorem to compute the corresponding moment of inertias of y minus y naught square. Okay. And here again the thing to be noted is the modular ratio comes about here, okay, where it will affect the width of the cross section alone. Okay. So, if I add a cross section which is of this form as an equivalent steel section, equivalent wood section, where I make this m times b, when this is b, I will get, since the heavier area, more area is there at the bottom, the CG will shift towards the bottom. So, I will have it the CG as here for the cross section y CG of cross section, and this will be Z CG of the cross section, and this distance would be y bar, y naught, this distance would be y naught as we computed before, and for this cross section if we compute the moment of inertia be same as what we have got here. Okay. So, we have computed essentially the ingredients that are required to solve the problem. So, essentially we have computed y naught for the cross section and this integration for the cross section. So, remaining steps remain the same as it is for the homogeneous cross section. To get delta y, you have to integrate this equation where mz is a function of x. To get delta y, to get the stress, you use the fact that it is Ey times mz into y minus y naught divided by Ey times y minus y naught whole square dA. Okay. So, you use these facts to compute the moment or the stress respectively. Okay.